In this section of notes, we will expand what we learned in the last section regarding discrete random variables. We've already talked about expected value and mean. Now we're going to move over to variance and standard deviation, and we'll also start looking at continuous random variables. So remember that to find the mean, we take each of the x values, multiply it by its probability, and then take all of those values and add them up. So within that, once we have that mean, that is this mu sub x that shows up in this formula to come up with the variance. And then of course we know that the variance, you'll take the square root of that. Once you take the square root of that, that will give you the standard deviation. Remember in chapter 1, we worked through how to do a standard deviation by hand, and then we said you're never going to do it again, you're just going to use your calculator moving forward. That would be similar to this. So you would take your list of values, put those in L1 in your calculator, your list of probabilities, put those in L2, do your one variable statistics, and just like we mentioned in the last section where that will give you your mean, it will also give you your standard deviation. So just as we did before, we'll do one by hand, and then moving forward, you'll use your calculator. So here's an example where we have different APGAR scores and the probability of a baby who's randomly selected getting that APGAR score. We mentioned in the last section how you would find your mean, so we'll assume that we've already done that and we've found our mean. And then we're going to take each value, subtract the mean, square it, and then multiply by the probability, and then add all of those up, and then that is what gives us our variance, and then we take the square root of that to get our standard deviation. Now in terms of how you interpret your standard deviation, we're going to use that same fill-in-the-blank sentence from back in chapter 1, where we say that whatever our y context is, it's going to typically vary from whatever the mean is. So in this case, the randomly selected baby's APGAR score will typically vary from the mean by about 1.4 units. So now let's move over to continuous random variables. Previously, we had defined the difference between discrete and continuous, and we talked about how discrete has certain outcomes possible, and then there's gaps in between them, whereas continuous takes on all of these values within some interval. So you can't just find the probability of each outcome and then add those values, because we don't have individual outcomes. There's always another one. If you go out another decimal place, you can get smaller and smaller increments. So that means we're going to have to do something ultimately ending up being related to some sort of a curve, probably a uniform curve or a normal curve in most situations, since that's what we know how to work with. So let's take a look at this example. In this example, we're working with the normal model. We know that the heights of women are normally distributed with a mean of 64 inches and a standard deviation of 2.7 inches, and we want to find the probability that if we pick one of these young women at random, that they're going to be somewhere between 68 and 70 inches tall. So just like we did in chapter 2, we would label our normal curve with the mean and the standard deviation. We'd shade in the area that we were looking for. And then we can either do this by hand using z-scores and table A, or we can use our calculator. So let's start with using our z-scores. So if we're going to use our z-scores, we would turn each of the endpoints of our interval, the 68 and the 70, we'd turn those into z-scores. We'd go over to table A, and we'd find the probability of getting a z-score less than or equal to each of those values, and we take the larger one minus the smaller one to get what we were looking for. Now, of course, the other method would be to use our calculator, and that's where we would use our normal CDF, lower, upper, mean, standard deviation. Don't forget, if you're going to use your calculator, you must still show work, so you must still have a sketch with shading. and you must still say lower upper mean standard deviation, so the inputs that you're using on your calculator. As usual, make sure you try the practice problems from this section before moving on